So what was it that actually triggered the situation on testnet that needed to be recovered
Uh,
from the?
okay,
Am I correct?
I will do an in-depth explanation. Okay, I will attempt to do an in-depth explanation because it's a really complicated protocol. Um, so so there are headers and blocks. Um, and what Bitcoin Core does is it downloads. So originally, it would get both headers and blocks in sort of in parallel, but it only looked at a single node, and that's still the case. So it would pick one node out of its peers that it thought was good and get the headers from that. At some point, they changed to try and get as many headers as possible, and then download the blocks. And the reason for that is that if you're after a checkpoint, then you basically know that you're on the right chain, and you don't have to do as much validation on the block. So that's an efficiency improvement thing. Okay. The way that a node is supposed to answer get headers requests is relevant to this bug, and it's a little bit clunky. There's a maximum number of headers that will fit in the response to a get headers message, and if the responding peer sends the maximum number of headers, that's considered to mean that there are more headers to come. So it's not at the end of its chain. If it sends fewer than that number of headers, then that's a weak indication that it was at the end of its chain, and so we might delay. We don't conclude that there are any more blocks, any more headers to fetch. So Zcash which does not have the headers first change, so it's still downloading headers and blocks concurrently. It had a bug inherited, an efficiency bug inherited from Bitcoin Core. This is the bug that from 2015 that was only fixed in 2022, where it would send redundant get headers requests. So it's basically supposed to just send get headers for the ranges that it actually needs in sequential order. But it actually will send additional requests, and that was causing much greater bandwidth usage. So Zcash when syncing, would take several multiples of the bandwidth that it actually needed. And so let's see. So what Zebra did to try and compensate for that is not to send the full the maximum number of headers in any given message. So instead of sending 160 headers, if it had more to send later, then it would send 158. And for the network at the time that workaround was put in place, that sort of worked reasonably well and avoided the bandwidth efficiency problem from Zcash. But in a different situation where it's the Zcash nodes that have the authoritative chain, and it's the Zebra D nodes that have the authoritative chain, and the Zcash nodes are trying to catch up. The effect of not sending the full the maximum number of headers in each message was that so a Zcash node would sync much more slowly because it would think that it had reached the end of that chain when it's connecting to a given peer. And it only connects to one peer, which exacerbates the problem. So what was happening was that when the peer mined another block, or when it sent an inf message, I think it was, it kind of would get unstuck. So it would load 158 headers and then wait for the next block to be mined, and then on another 158 headers, and so on, instead of loading the headers continuously. And this made the sync take much longer. So yeah, that was the efficiency bug that was introduced by this change. That it became an emergent bug due to this change in ZBruD. And so what we did to fix the network, well, we did several things. This all interacts with another thing called the max tip age. So if no blocks have been mined for 24 hours, then the network will break, because that's not an expected condition. And in the normal situation, that would normally indicate that your clock is wrong, for example, or you're on a fork and you shouldn't continue. So it's reasonable that that rule should exist, but in a situation where no blocks have been mined on the network for a day, and in this case it was no blocks have been mined for 7 days, then it creates a big problem. So what we did to work around that was just to increase the constant, which is normally 24 hours. I just increased that to 10 days. And that got the particular nodes that I was using to catch up to see that we would near enough the tip, and they were able to mine. And then there was another bug in Zcash where so there are constraints on the timestamp of blocks. So the timestamp of a block has to be greater than the it's called the median time passed. So it's a kind of average of the last 17 block timestamps. The details don't really matter, but it also cannot be too far in the future relative to the median time passed. So it can't be more than there can't be a gap of more than 90 minutes between the median time passed of a block and its timestamp. And so if you try to mine a block just using the current time when you're in the situation where the network is broken, then it won't work. So what you're supposed to do really is to clamp the block time to the maximum time allowed by the consensus rules. But let's see, Zcash, so ZBruD was doing that. Zcash was trying to do that, but there was a bug. And so we figured out what the bug was, did a temporary workaround, and then Zcash was able to catch up.
Yep. And
the other thing that we did, was just manually figure out what the best chain was, and then do add nodes to create a well-connected network between those nodes.
Also, I did verify that that without the max tip age setting, that a Zcash node can now sync, and it is in current state. So testnet is healed.